Welcome to session 6 of the PayPal session. Let's start with a recap of session 5. So in session 5, we covered the dot-com bust and how PayPal had raised a $100 million round so that it had money even though the dot-com was going through a bust. Also, we covered how eBay was very important to PayPal as the beachhead for power sellers, and how PayPal was able to get the PayPal mark on power seller listings. We also talked a bit about bill point. So eBay ended up buying PayPal, but initially, PayPal was very important for eBay was very important to PayPal, and yet it was a competitor. It had a payment service called BillPoint, which they were trying to promote. So the key challenge that PayPal had to overcome was how to kill BillPoint and get a large number of sellers and buyers on eBay, which was one of the major transacting platforms at that time, to use PayPal as their payment method and not BillPoint. We also looked at the PayPal coup, where Elon Musk had to step down as CEO and Peter Thiel came in as interim CEO. And we identified one of the key problems that PayPal needed to solve, which was the deadbeat problem. Now, this session is going to be devoted entirely to the deadbeat problem and how PayPal solved it, because this, along with some of the other innovations that PayPal did, like getting to place the payment mark, using CAPTCHAs, the random deposit invention, and so on and so forth. These are just a few of the innovations that PayPal made, which enabled PayPal to be successful in a space where close to 70 companies failed, and PayPal emerged as the dominant player and a very successful company. Okay, so let's move on to the deadbeat problem. Now, the deadbeat problem, just to refresh your memory, is the problem where a buyer buys a product and then charges it back or refuses to take delivery or whatever. So basically the seller has done everything right, but the buyer says that they've done something wrong and convinces their credit card company to send a payment, to charge the payment back. Now, this is a double whammy for the seller. They're out of the goods. Plus, they have to go through all this processing of the chargeback, which is expensive, and it could also damage the reputation of the seller. Now, there's some control that the banks have where they try to prevent buyers from charging back too many items, but this can still be a serious problem for a seller. So the sellers, and quite a few of these people are first-time sellers. They're very small sellers, so they don't have the capacity to absorb chargebacks. So this is the key thing that sellers are looking for. They want protection from deadbeat buyers. Now, the buyers want protection from deadbeat sellers. That is, sellers who list items, don't ship the correct item, or ship the damaged item, or ship an item very late. So how do you solve this problem on the internet was a key challenge for all the people who were trying to provide payment services on the internet. And PayPal actually solved this problem. Now, this, to some extent, is also a problem in the physical world, because you could, there is something called white card fraud, where you could get a credit card charge where a waiter skims your card and then at a fraudulent merchant, your card is used where you never made a purchase. So that is like a deadbeat seller. Or you could again buy an item at a physical store or like through a mail order kind of thing and then charge it back. So that would be like a deadbeat buyer. So one of the ways that PayPal did this, which was very similar to eBay's reputation ranking, where if you wanted to see how many sales has the seller done, what kind of satisfaction rating does he have from people who purchase his items, and so on and so forth. So PayPal did something similar, saying how long has this person been a PayPal member, how many payments have they made, and things like that, right? So those were certain tools that PayPal used. But then the key thing that PayPal needed to do was to find a method where people could shop with confidence on the internet. Right? So, and solve both these kind of problems. So to do this, we formed a team saying, like, how does this kind of fraud get controlled in the physical world? So I had some experience of that, and so I told our technical team as to how some of these frauds were controlled in the physical world. For instance, say someone steals your wallet and gets your credit card. Now, one of the things that they used to do at that time in the physical world was to see whether your card is working or not. They would take your card and they would swipe it at a petrol pump. Now, this petrol pump may be a pump where you normally did not swipe and fill petrol. So if a credit card company got a charge at a petrol pump, which was not your normal petrol pump. Now you could be traveling, so this could be a legitimate charge. But if they got a charge and then immediately got another charge or very soon got another charge, which looked like away from your normal purchases, then they would flag your card and stop it from fresh transactions. So this was just one example of how credit card companies tried to limit fraud on physical cards in the physical world. So now we wanted to translate this into the internet world, and we had several advantages because we could see from which IP the accounts had been opened, how many accounts had been opened, because normally, so we started trying to look for patterns. So we said, like in a physical world, if a person puts on a mask and draws a gun, then you probably know that they're going to rob the bank. So what would be the patterns that fraudsters who wanted to commit fraud on the internet would do? And one of the benefits that we had was that suppose you committed fraud, right? Whether you were a seller who was committing fraud, and then you would want to withdraw that particular transaction. So you'd want to withdraw all the money based on the fraud that you had committed, right? So we could restrict withdrawals from the account because a person, initially when the payment came, it went to to the seller's PayPal account from the buyer's PayPal account. And we could see that, right? So then we did the system where we had like about a 4-hour window where before we said, okay, now you've placed a withdrawal request, we are going to send you the money. So we could, in that period, block the money being sent. So a system was built using pattern recognition and artificial intelligence to identify patterns that were fraudulent patterns. And then based on these patterns, they would, those that were detected as suspicious would go to human operators who were presented with very nice tools, visual patterns, which actually showed them how the money moved, where the accounts are opened. And the combination of this artificial intelligence, this pattern recognition, and the humans ended up helping us prevent fraud. So then we were able to tell people that, look, if it looks like there's a fraudulent seller and all, and you get caught, we will be able to restrict this person and get you your money back. This kind of thing of deterring fraud on the internet, and like having people, use stolen cards and various other kind of things to get money, PayPal was very effectively able to block, and the fraud rate on PayPal dropped to lower than that in the physical world, which was kind of amazing and gave PayPal a huge leg up on the competitors. And even to this day, some of this innovation that PayPal has done makes it very successful. Now, another very interesting piece of the design was that in any system like this, you can have what are called false positives and false negatives. So false positive would be that I go and restrict an account and say this is a fraudulent account, when actually it is not. And a false negative would be that there is an account which is fraudulent, but I don't catch it and I let it go. So these were the two types of errors, and we were very well aware of them, and we were tracking them. And then when those errors occurred, we would try and learn from them and improve our pattern recognition system and our human system, right? So it was a learning system. Now, the thing with this was, what was interesting was that in the design, we had two choices. One is that we could keep the system very tight and restrict a lot to prevent the false negative errors. So we won't want to lose money. Or the other way we could do it is that we could have a relatively loose system, in which case we won't restrict so many accounts, but we would end up losing money. Now, PayPal very consciously made a choice to keep the system loose initially so that we would learn. So we'd lose money, but we'd learn. And then we would tighten up in the right way. Because for us, the loss of reputation, the loss of business by incorrectly restricting a person's account had a much higher cost than the money that we lost, right? So this is how PayPal was very successful, and fortunately it had the capital to be able to sustain this kind of design. So by now, because of the referral system, which later PayPal stopped, but the $10 that was given, the $10 for referring someone, and the various other costs, now the team had grown to becoming quite large. We had offices, we had fraud losses, and so on and so forth. We were rapidly burning through money. So I still remember that, we had burned through about like $185 million before PayPal kind of broke even. So it was quite a lot of money that PayPal ended up burning through before it broke even. Sorry, not 185, but $85 million. So now when you're burning through that kind of money, Even though you've raised 100 million, you need to raise more money. And PayPal managed to raise another $90 million, even though there was the dot-com bust. But we'll cover that in the next session. Thank you very much for listening.